All right, nerds. So we're getting into it now. We're moving beyond physics, which is kind of what we've been talking about, and we're now moving into the chemistry of it. And this is where it starts to get a bit more interesting. So first off, what's the point? We want to explain the differences between chemical and physical change. That's kind of revision, and that'll take but a second. Then we want to identify the signs of chemical change. That's a bit more intense. There's a lot more going on. Then we're going to finish off by just going through what is an equation, what is a chemical equation, and we'll get there, okay? So no real dramas today. First off, physical change and chemical change. Let's compare them. Physical, that's wrong. Okay, so we make that one there. That becomes chemical properties. In a physical change, the chemical properties don't change. They stay the same. Okay, so chemical properties are how something reacts with another thing. They don't change in a physical change. It's reversible, and that's important. So, you know, if we go from ice to water, still the same stuff. We can put it in the freezer, it'll go back to ice. No new substance is formed. So even though we call ice, water, and steam different things, it's the same. It is hydrogen and oxygen bonded together to look like this Mickey Mouse-ears guy down here. Alright, chemical change, however. Again, chemical properties. I don't know what I was thinking when I wrote that down. The chemical properties do change. That's important, okay? The reason they change, well, also, it's irreversible. Irreversible, what that means is you've got to put a lot of energy in to make it go back, all right? And sometimes you can't even do that. Now, anyway, the reason the chemical properties do change is because you've made a new substance. Atoms have rearranged to form a completely new thing. For example here, water to hydrogen peroxide. You can see that we've got a completely different chemical here. It's the same elements. Yeah, you've got one oxygen, two hydrogens. Now we've got hydrogen, hydrogen, two oxygens. If you drink this one, you'll survive. In fact, you don't get too far without it. If you drink this one, you'll die because it reacts with your body as it goes down and eats it away. So the chemical properties are different. All right. It's important to remember, though, all changes involve a change in energy. That's what causes change to happen. All right, so let's have a quick summarize and just see if you can label each one of these as a chemical or physical change before we get there. And we'll zoom through these. So boiling water, that's a physical change. Fresh lemonade, that's a physical change. That's actually just making a mixture. We don't really make any new, no new chemistry happens. Baking a cake, that's a chemical change. So stuff changes. Digesting food, that's a chemical change. You break the sugars down into carbon dioxide, which you breathe out, and water. In fact, that's the same as burning. It's kind of a combustion. Fireworks, that's a chemical change. Mowing the lawn, you just made the bits of grass smaller. That's a physical change. Okay. So there are 5 signs of chemical change that we are concerned with. First, bubbles given off, gases liberated. Cool. A color change. Sweet. Temperature change. Not a drama. Precipitate is formed. That's different. We might not know what that is yet. We'll get there. Light is given off. Boom. It's like an explosion. Okay, so a gas is liberated. Here we see bubbles coming off. All right. Liberated means release. A gas is released, and this is indicated by bubbles. So this is nothing mind-blowing yet. There's a conclusion. The new chemical substance formed is a gas. Okay, so we can draw conclusions from each of these observations about, or signs of a chemical reaction. A color change. All right. So the color of a substance changes. What's going on here? Get rid of that. The conclusion. A new substance with different chemical properties has been formed. Okay, the color of something is a chemical property. Temperature change. This one's a bit more interesting. So first, the temperature changes. We've seen this. If you're burning something, That's a chemical reaction. Exothermic reactions give off heat. They release energy with the chemical change. Cool. An endothermic reaction draws energy in, so everything feels colder when you touch it. And they use chemical energy during that chemical change. So exothermic and endothermic, you need to know those words. They're both very, very important. Basically, the chemical change has occurred since an energy change was involved. Cool. All right, a precipitate is formed. Here we have two soluble substances that we're about to mix together, and we get this solid. That's a solid forming. So soluble, soluble. Okay, so we mix two solutions, a solid forms. That's a precipitate. The solid precipitates out of solution. The conclusion that can be drawn is that the new substance formed is insoluble. All right, light is released. Basically, this is the similar, well, it is an exothermic reaction. Well, we'll say it's similar to an exothermic reaction. It usually is exothermic. Light energy is released during the chemical reaction. And we'll see this with pretty much any time you burn something. Energy is released from the breaking of bonds or the formation of more stable bonds. Okay, so if you've got something that's very unstable, that means it's holding energy. And when it settles down, that releases energy. Okay, so it forms its stable bonds, it releases energy. All right, this is where we finish off. I hope that was all made sense. There's only 5 there. Get those down, pretty straightforward. The anatomy of a chemical equation. So these are how we represent chemical change. Anytime we do a reaction that involves chemistry, if either I or your teacher forget to give you the chemical equation or forget to show you how to do it, you make sure you ask us, because we should have the chemical equation for each chemical change we do. Alright, so you can do word equations or formula equations. They've both got the same format, and that is essentially reactants on the left, products on the right. This little arrow means goes to, so the reactants go to the products. It's never an equals. It's not an equals. It's not this thing equals that. It's this goes into that. So reactants to products. We're going to give you an example here. Magnesium plus oxygen. So if we burn it, that's what adding oxygen. That's how we add oxygen stuff. We set it on fire. Magnesium plus oxygen gives us magnesium oxide. Mg plus O2, because that's how oxygen exists in the atmosphere, gives us MgO. Now, let's have a look at something. How many oxygen atoms do we have on the left-hand side? We've got 2. How many on the right? 1. How many magnesium atoms do we have on the left-hand side? Well, we've got 1 and 1. So this means we have 1, 2, 1, 1. Okay, now we have a problem. We have a very serious problem, actually. If that's how the chemical equation stays, we've just broke the universe, because we've violated the law of conservation of matter. Now, this is a big deal. You can't do that. Again, the universe falls apart, everyone dies. So, let's not break that law. Basically, earlier we said a chemical change is a rearrangement of atoms. Alright, so what this actually means is, and you will learn how to do this later on, we put a 2 at the front, right? This now means we have 2 magnesium atoms, 2 oxygen atoms. If you've lost your place and this makes no sense, you can kind of stop here and we'll come back to this. Okay, so you've got 2 magnesium atoms, 2 oxygen atoms. Now, over here, so we can change that number to 2, that number to 2. The universe still isn't saved. We've got a problem. We've now got 2 magnesiums, 2 oxygens, 2 oxygens, 1 magnesium. Okay, well that's actually not too hard. It means if we put in twice as much magnesium as we do oxygen, we'll get this. And if we look at this, check it out, check it out. Boom, the universe doesn't need to end. We have 2 magnesiums, 2 oxygens. 2 magnesiums, 2 oxygens. We're safe. That's called a balanced equation. We'll get into more in that probably the next 2 lessons. So enjoy. I'll see you in class or in the next lesson.